Hello, everybody. Thank you for joining. I believe this is one of the last sessions here at Summit. So we'd like to think of it as sort of a closing keynote. Thank you. Thank you all for being here. My name is Ari. I'm a software engineer at RelationalAI. This is Chen. He is also a software engineer at Observe. And together, today, we're going to be talking to you about building AI platforms on Snowflake and what the observability challenges are that arise in such a context. So this is our faces, for those of you watching the recording. All right, agenda for today. Quick introduction of our respective companies. Then I'm going to be talking to you about how RelationalAI built its AI platform on Snowflake and what kind of observability challenges we faced. And then Chen is going to talk to you about building Observe on Snowflake and how Observe integrates with Snowflake observability. I'll be doing a live demo. I'll be showing you Observe in the RelationalAI tenant and some of the cool things that we can do there. And then we'll talk about takeaways and what kind of things we want to do in the future. So, RelationalAI helps businesses make better and faster decisions in Snowflake. We do that by modeling your business with a relational knowledge graph that combines your business logic and your data in one model. Once we have that, we can run complex or different types of reasoners on top of that model to help you ask and answer hard questions about your business. All right, so let's look at the diagram. Let's start at the bottom. You have your data that is in Snowflake, and it's important to understand RelationalAI ships as a native app that runs in your Snowflake account. There's no data movement involved. There's no exfiltrating data into some other system. Moving up one layer, we have the reasoners. We support Snowflake's reasoners, the ones in blue, SQL, Snowflake SQL engine. We support vector similarity search. In some cases, you want to go beyond what SQL can offer for you. You want to maybe do rule-based reasoning. You want to have a set of business rules, and you want to define, infer new types of rules from that. Maybe you have a very complex system and you want to do pathfinding. You have a graph. You want to do something that is not easy to do in SQL. In some cases, you want asking hard questions often involves doing some sort of prediction. You want to use GNNs. Maybe you want to do, I don't know, some demand forecasting, or you want to come up with a pricing model or something like that. And you might want to do prescriptive reasoning. Maybe you have some constraints that you want to solve a problem for while maintaining those constraints. You want to do mathematical optimization, linear programming, something like that. These reasoners are built into the relational knowledge graph. You can think of that as a set of concepts and relationships between those concepts. And those can be defined, but you can also infer new relationships. So this is a model that is executable. You can query against this model. We integrate well with Snowflake's dimensional semantics offering that they announced this week, semantic views. You can go between our relational knowledge graph and Snowflake semantic views back and forth. Now, you can interact with our system using a Python API, but you can also use a UI, and that's where the GenAI reasoner comes into play. So we have an LLM that is fine-tuned or super aligned for your business domain, with the relational knowledge graph that forms the semantic layer of your business. So it understands your business, and it understands how to use all of these reasoners with the relational knowledge graph to answer hard questions about your business that you can just ask in natural language. Okay, I'm going to go over some examples that maybe give some more context or allow you to understand this a bit better later on in the talk. And if you want to know more, there's a bunch of talks we've had at past Summit and Build events. And you can come to our booth, 2412, 2412. We're happy to show you demos and go over some more detail if you want. Here you go, Chen.
Observe is a cloud-native SaaS observability platform that we built for fast troubleshooting and low cost while processing a large amount of telemetry data. So there are several things that we've done differently to allow us to do this. So in the basis of this abstracted architectural diagram is a very high efficient real-time ingest pipeline that can ingest up to more than petabytes of data per day per customer with sub-minutes latency into a unified data platform. And we also built a context-aware knowledge graph, which is like a graph of data sets that we transform with a very high efficiency our algorithm, so to help you fast troubleshoot and pivot between different observability data types like log, metrics, and traces. And we also built a bunch of out-of-the-box integrations so that you can analyze your services and integrations like EC2 instance, Kubernetes cluster, your cloud infrastructure, AWS, GCP, Azure, and many other integrations, as well as databases. So on top of this data platform, we built a bunch of services and explorers that will help you fast analyze your data. And as well, we also have a observability AI investigator that allows engineers to troubleshoot known and unknown problems on top of your telemetry data using using natural language and to create worksheets, create dashboard, or even incident report. So all of this is built upon a data lake foundation, which is the most cost-effective way to store your telemetry data. So at the core, we believe that observability problem is a data problem. That's why we choose to store all your telemetry data, logs, metrics, and traces into a single platform for fast analyze and pivot. So as you can see, Observe is a full stack end-to-end observability platform with many use cases. To learn more about the architecture of the general architecture of the platform, as well as how we build a semantic layer, transform layer on top of this data plane, feel free to visit our website and read our blog, or go to watch the summit talk that we did last year. For the sake of this presentation, we'll be focusing more on Snowflake observability. So now I'll go back to Ari.
Thank you. All right. Gave you a little introduction on what we do as a company. Now I want to talk about specifically how the native app that we ship is built and how we use observability in its context. So there's three main layers here. And all of our components are built directly on Snowflake. On the top, you see two components, the API and the data integration component. The API is just the front door to our application. Everything has to go through it. And the data integration layer handles the interop between your data and your Snowflake account. What we do is we build what we call a graph index on top of your Snowflake tables, which is a highly normalized representation of data that lends itself well to all of the different types of reasoners that we have. These two components are built with SQL UDFs and stored procedures in SQL and JavaScript, and they run on Snowflake warehouses. Then we have the control plane, that's a singleton that runs in a Snowpark container, and the control plane basically orchestrates our reasoners and dispatches transactions to the relevant reasoner. And of course, we have our reasoners. There's like a dynamic number of them based on whatever the customer is querying right now. You can have maybe five rule reasoning engines, 2 graph reasoners, etc. So it can get really complex. There can be a lot of containers running at the same time. And then, of course, we have the relational knowledge graph, for which we use Snowflake native app storage. Again, all of this is running in a Snowflake native app directly in the customer Snowflake account. Customer data sits in that account, and we interop with it, and there's no data movement. So because all of this runs in the customer account, it's really important for us to know what's going on. We don't manage this infrastructure. We have really no way of fixing an issue or even knowing that there's an issue. So we need telemetry, right? every component here that runs in some sort of compute produces logs, traces, metrics. So in our API component and our data integration component, we use regular SQL interfaces to produce logs and traces as well. And in our container services, we use Snowflake's OTel collectors to produce logs, traces, and metrics. And there's a lot of them. From what I hear from our friends at Snowflake, we are one of the top telemetry producers in the event table today. All of this is great. Now we have it in the event table. And by the way, for those of you who don't know, the event table is a special type of Snowflake table. It's a managed table. It has a predefined schema that is compatible with OpenTelemetry. And Chen is going to go over that a bit more in the future, in future slides. All right. Now, we have all of this data, and we need to get it to our observability platform. So in the native app model, there's a consumer and there's a provider. So everything I've just been showing you happens on the consumer account. And in our case, those are customers running our native app in their account. Now, all of that telemetry lands in what I'm calling the consumer event table here. That's just the event table in the consumer account. And then gets shared with what is called event sharing to the provider event table. Now, the actual details are a bit different. I believe the telemetry is written directly to the consumer event table and the provider event table. But for the sake of this talk, you can just think of it as event sharing. And there is one provider account per region. So if we offer RelationalAI on Snowflake, AWS, US West 1, then there's multiple customers that we have in that region, and all of them share event table data with our provider event table. Now, we need to get that data that we get, that telemetry that we get in the provider event table to our observability platform. We run pretty sophisticated reasoners. We have requirements for telemetry that go beyond what we can do today with Snowflake Trail. Like we need complex dashboarding, we need complex monitoring, we need all telemetry data from all of our 12 regions. So we have 12 regions, 1 billion events per day approximately that come in, and we need one unified place where we can do alerting, monitoring, dashboarding, investigations, all on top of that. So what we did before we partnered with Observe was something that's pretty complex. You probably can't read this at the back. Doesn't really matter that much. The main takeaway is that it was a pretty complex and elaborate setup. So we had to do a bunch of CDC with streams and tasks on the provider event table that pulled out our different types of telemetry, and we dumped it into an S3 stage. And then we had Snowpark containers where we ran OTel collectors that pulled in data from the stage and sent it to our legacy observability platform. This was complex to maintain. We at RelationalAI, we're not experts at observability infrastructure. We don't want to be. We don't want to be, right? So we spent a lot of time fixing this, spent a lot of time with Snowflake engineers working on this. Some of them are in this room. Hey, Max, appreciate you. So yeah, what we did is we partnered with Observe, and that really simplified our architecture diagram a lot. We can now install the Observe Snowflake native app, O4S it's called, and it's a really seamless experience. It's just like a one-click install on the marketplace. It takes data from the event table and puts it into Observe. And what was my problem previously, figuring out all of this infrastructure, what to do when it fails, is now Chen's problem. So I'm really happy about that. Okay. So we at RelationalAI, we've really enjoyed this partnership a lot. Here are some reasons. I think it all boils down to this native Snowflake integration. Observe is built on Snowflake, is natively integrated with Snowflake, and they understand Snowflake. RelationalAI is built natively on Snowflake as well. So lower cost, that's a big deal. So the overall cost with Observe is much, much lower than it is with our other legacy platform, observability platform. The cost model that we have in Observe is much, much simpler, and it's ingest-based, and it's easy for us to plan for it, and it's easy for us to control how much we spend. That wasn't the case with our prior solution. We had basically almost a full-time engineer to manage cost and figure out how all the creative ways that they used to overcharge us. There's lower initial engineering and implementation costs because we don't have to manage this infrastructure in every region. We don't have to set it up. We don't have to fix things when it breaks. And there's lower ongoing operational costs. Our solution used a lot of compute. Now, I'm not saying it was an ideal solution. We're not experts in that area. Observe's solution still requires compute. There's a warehouse that's running with the O4S app, but it's lower. The cost is lower. There's a better user experience. As I will show you a bit later, we have some pretty complex requirements for our observability. So we love Opal, Observe's processing and analysis language, which is, you can think of it as a DSL for observability data, and it compiles down to SQL, but it allows you to pipeline things in a very easy way and like do data transformations. And doing that in SQL, like in vanilla SQL, is not a nice experience. And yes, no need to maintain our own observability infrastructure. I covered that already. Security is a big thing. So Observe offers a connected app model where your data doesn't leave your account. And open data. We control like our own destiny. We have full access to our shaped observability data in Snowflake. And for us, this is huge because we can run RelationalAI on our own telemetry data. So everything I told you about before, creating a model of your business, running complex types of reasoning. We can now do that. We can do that to ourselves, basically. So I'm going to talk to you a bit later about interesting use cases for reliability engineering, security, and cost optimization that unlocks. All right, over to you, Chen.
Thank you, Ari. So Ari just mentioned the necessity of having observability for Snowflake app developers, and if you develop app and distribute to your customer. So I'm going to talk about more use cases that we see internally, and why Observe is an expert in the Snowflake observability space. So as I mentioned before, we are a full-fledged observability solution. We provide all different kinds of use cases and functionality like infra and application monitoring. We have a new APM offering just coming out today, distributed tracing, log search, service monitoring, alerting, and customer dashboard. All of those use cases are enabled by our modern architecture. So this is a little bit more technical diagram than the previous one, but basically it's share the same idea. From the left to right, you see data generated in the open telemetry format from different sources and into our data lake and being computed by the Elastic Compute. And we built data graph on top of it, and we can use different kinds of API, OPAL, or observability AI natural language interface to interact with the data. So at the core of this is Snowflake. We use Snowflake as our backend, which means when customer sends a query against our data set, we send query to Snowflake. And for every interaction against data in our platform. So this naturally makes Observe a big user of Snowflake, and our footprint on Snowflake is massive. So this is the latest data that we got internally, and because we are an observability company, our metric tend to be very accurate. So on average, we run 200 million queries in all of our deployment across different Snowflake accounts. So according to Snowflake's latest number on their own website, they run their customers run 6.3 billion queries globally per day, which makes us running on a daily average 3% of Snowflake query across all the deployments. So we have 26 petabytes of compressed data stored in the Snowflake's storage layer, and we ingest petabytes of data into our customer tenants, and also we have approximately 250,000 warehouse resume on a daily basis. because we have some very sophisticated algorithm that help us do cost control and resource utilization on Snowflake. And at any given time, there are thousands of active warehouses running queries and transformations on Snowflake. So this makes a Snowflake observability a must-do for us, and and over the past 8 years, we've become an expert in understanding the Snowflake usage, and we already built for the past few years, we already built an in-house solution to help ourselves like analyze our own Snowflake usage, like query performance, warehouse health, like what's going on with our data pipeline. And with this use case and this need, combined with the new requirements from our customer, like RelationalAI on the observability on the Snowflake, of the Snowflake's data product, we decided to build our experience into a product offering, aka a Snowflake native app, so that other Snowflake users and application developers can use it and benefit from it. So now let's talk about our app. It is called Observe for Snowflake, aka O4S. It is a native app that track mostly, for now, those three different categories of data from Snowflake. System usage table. As you know, there are system views from inside each customer's Snowflake tenant about the usage of your account, such as login history, copy history, table views, or even grant. And also in the second column, like Ari just mentioned, event table, which is a new thing for application developers and Snowflake users to understand the usage and the internal telemetries of their application and data product. And event table, just to reiterate, it is a special kind of database table that's read-only from the customer side, and Snowflake figure out a very efficient way to ingest and get telemetry, internal telemetry data into such table. And this table is open telemetry. The schema of this table is open telemetry compatible, which makes a consumer much easier to pump those data or use the data in the industry standard way of open telemetry. And of course, if customer figure out their own data pipeline somehow into a existing view or table, we can actually just pump that table into Observe. So more on the event table, in case you are wondering. So it is a core concept in the whole Snowflake Trail offering, and from the left to middle, Snowflake already figure out a very low latency, low cost way of ingesting all the telemetry data from the different kinds of data products throughout the platform, and we do the second step of pumping the event table into our platform and doing more shaping to get more value into for the customer. So we can do a very quick overview of the internal architecture of our app. So we are basically so O4S is a native app, not as Snowpark container service, because we figure out it's sufficient to just using all the building blocks from Snowflake, like to put everything together like a Lego. It is effectively act as a data collector or connector that running inside customer Snowflake account and pump data to our platform. So as you can see in the blue box is Snowflake's customer Snowflake account. And we, at the core of the native app, are a bunch of serverless tasks that's running at fixed schedule and with resiliency and scalability to keep pumping the data from those system views into our own collection endpoint. and so that you don't need to run. So you just need to open the task, the native app, configure the task, configure the connection, and then it will run in the background for you. You don't need to reopen the app, and as you can see, we are using some other technologies like external access integration, so that the data can be sent outside of Snowflake into our platform. Stream, so that we can see the latest change of the new data into those system views. We built a Streamlit UI, and of course, in those Python tasks, we extensively used all the different Snowpark libraries and functionalities to pump the data in a very efficient way. Just a quick overview. We have OK Streamlit UI, and to help you manage your task and schedule, easy to understand and use. And while the data are being pumped to our server side, we also built a out-of-the-box content and we shape the data to observe data set, which has more rich information and metadata of different things that's in Snowflake, like metrics, logs, traces, and things like tables and accounts, etc. So you can click around those columns, and you can also pivot to different data sets and log of those things when things happen. For example, once you set up the connection to O4S, you are able to see all kinds of metrics, and this is a warehouse metering history metrics. And of course, we built a bunch of dashboard for you to analyze your Snowflake usage. So at the end, this is kind of a summary of what we just described of our deployment architecture. In the middle is the RelationalAI customer who's running their software and their Snowpark container service, and those telemetry data are being sent to customers' event table, and Snowflake figured out already to share those consumer event table back to RelationalAI, and in the RelationalAI account, we were able to, they run this Observe for Snowflake O4S native app that subsequently sending those data all the way to the RelationalAI's Observe account. And we, having one RelationalAI Observe account, we allow you to send the, traffic from multiple, even tens of Snowflake account from RelationalAI. So, cool. I'll give it back to Ari.
Thank you. All right, it's time for a demo. Let me see if I can get this to work. So, okay, I'm going to show you Observe as it looks like when we use it. This is all real data. It's internal data, so nothing customer-facing that is going to leak here. I might need to maybe make this a bit larger. Can you see it? Okay, so I'm just going to start with something super basic. There's a log explorer. You know that from other platforms. You can look through our logs here. An interesting point here is that we can define our columns ourselves. We can define a service column, an environment column, and these columns contain links. So if I click on here, does it work? Okay, so I can go to some other related objects here. I'm not going to do that here. I'm going to do that in a more interesting example later on, but just to show you. And then this is maybe these are attributes. We can pack a lot of them in here. Just want to give you a feel for the UI. And we can use a bunch of data sets here that allow us to use them as logs. And there's a bunch of filters down here. So this is all pretty basic stuff, but works really well. It's good. Then let me just quickly go to the Trace Explorer. You can do the same thing for traces. Again, all of this is configurable. We worked with Observe to make this, to tailor this to our needs. And let me maybe take a look at this trace here. It looks a bit interesting, 27 seconds. I can go here. There's a waterfall view. There's a flame chart. Great. We use that a lot. There's a bunch of fields and attributes here. So where it gets interesting for me personally, I mean, this is all great, but in some ways this is table stakes for an observability platform. I want to look at the dataset graph. So before I do that, a data set in Observe, I like to think of it as like a view, basically, on top of your, because all of this is Snowflake data at the end of the day, right? And there's a view, and you can build data sets on top of other data sets and progressively shape your data to make it more interesting and more relevant to you. So let me just go to that. You're not going to be able to see this, I know that. But just to quickly show you, this is our data set graph that we built together with Observe. So on the left-hand side here, this is like very raw data. And we progressively make it more relevant, more interesting to us. And I'll actually go over an example a bit more later. But just to see, this is sort of the scope of our observability setup on Observe. This is one example. Let me just zoom in. Actually, let me get this out of the way. Zoom in a little bit here. So an engine, to us, it's like an internal name for one type of reasoner that we have. And we build a data set that's like a resource data set that contains these fields over here, an account alias, an engine, an environment, all of these concepts that we define. And we derive it from other data sets. So we start out with the Snowflake data set. That's where all of the raw event table data comes in from all of our 12 regions. And then we have reference tables as well. Just as a quick aside, a reference table, let me just see how I'm doing on time. A reference table is sort of like a static CSV that you can use to do things like map a Snowflake org string or an account locator that is like completely human unreadable to something that is more understandable by everyone in our organization. So we map all of those things, and then we can derive a data set that's an engine data set that is more useful and has exactly the telemetry that we want to see when we look at engines. So with this in mind, let me go to an actual real-life alert that we got last week. So Observe has monitors, right? And these monitors can trigger alerts. Now let me just quickly go over this. The title here says, a rule takes more than 1 hour to evaluate. So in our relational knowledge graph system, you can define business rules. And in some cases, with some queries, these rules need to be materialized. And sometimes there's a lot of rules, like one transaction can trigger hundreds and hundreds of rules that need to be evaluated. And if one of them takes longer than 1 hour, that's usually not a great sign. We maybe need to double click on that, see what's going on there. So there's a message here. This is a monitor on the duration of rules that take more than 1 hour, blah, blah, blah. And you can see the severity here, created by Ruba. Thank you, Ruba. And here's a link to the monitor. And here's where you can see, this is the first time we are showing this in this talk, this is Opal. This is a relatively simple example of Opal. Like we have monitors that are hundreds of lines of Opal. And you can see you can do filtering, create columns, do some more filtering. So in a nice pipelined way, you can switch these around, and it's pretty nice. And in this case, the input to this monitor is Snowflake logs. We can do multiple different types of telemetry in a monitor, right? We can join between logs and metrics. So this is all SQL under the hood, right? You can do joins, you can do aggregations, you can do all of that stuff. Now, you can see this is the context of the monitor, of the alert, I'm sorry. So let's look at the engine. So this alert is basically telling me, on this engine, something is going a bit wrong. Let me go and look at this engine. This is Andre, and I'm gonna. So this is really nice. I like this. I can click on this engine here, and I can look at the related assets. So if I go to dashboards, this is going to load dashboards that contain this engine resource. Now, you can see here, this is the RelationalAI RE demo version of the distributed workloads indicator. Now, this is, exactly the same basically as our real dashboard, but I made a clone just to make sure that nobody changes it before my demo. And the cool thing here is that the resource, this engine name, got propagated. The timestamp also got propagated, right? I don't have to copy paste and go search the dashboards that I need. And there's a bunch of dashboards, by the way, that could be relevant here. Now, in my case, I know that this is the dashboard that's relevant. You can see here, we have a bunch of metrics that we track. I don't understand half of them, but backend engineers at RelationalAI do. And I know now, because I was told, that I need to look at the transactions card. So I'm going to scroll down a bit. You can see we have a lot of interesting metrics here. We're heavy users of metrics. All right, finish transactions. Now, this dashboard is sort of like a general starting point for investigations that happen when we look at something that went wrong as an engine. So I'm seeing here this transaction with this UUID took a long time. Let me go and take a look further. So I'm going to click here and go to another dashboard that is more specific to the kind of problem that I'm trying to understand here. This is the optimizer dashboard. Again, the context got propagated, the transaction ID, the timestamp got propagated. And now I can go here and look at these rules and I can see, oh, okay, there's 4 rules here that took 2 hours and 30 minutes to evaluate, and something might be wrong here. So now our backend engineers can take a look at this and can make sure that customers don't run into this sort of issue again, and these types of rules get evaluated more efficiently. Okay, good. I think we're done with the demo. Let me go back. All right, takeaways and future directions. So the main, I think the overall takeaway here is that if you build sophisticated AI applications or platforms on Snowflake, you will need a lot of telemetry, you will need a lot of observability. And we love Snowflake Trail, and we know that it works well for a lot of customers. In some cases, you need to go a little bit further than that. And you will likely end up having to build your own observability infrastructure, same way as we did. Or you just go with somebody who's integrated really natively and well with Snowflake, like Observe. So we love the lower cost. We love the simple pricing model. It's great. We love the user experience. If you want to do powerful, complicated observability, dashboarding, monitoring, you're going to love Opal, you're going to love Observe. Security is important. We went over it. You can use it as a connected app where your observability data doesn't leave your Snowflake account. And then you have access to all of your observability data right in Snowflake. You can use it. And now this is where, for us at RelationalAI, this gets really interesting because we can run our own application on top of this data thanks to Observe. I want to go and look at some examples in this for reliability engineering, security, and cost optimization. So let's look at reliability engineering. Again, thanks to Observe, we can run RelationalAI on our own telemetry and do the thing that we said at the beginning, right? We build a relational knowledge graph that understands your business, that encodes business rules and your data, your telemetry data in this case. And everything that we did so far in the Observe demo, that's all SQL based, right? And it's great, we use it every day. To answer some really hard questions, we need to go beyond that. So for example, given the incident timeline, which signals should have triggered an alert to avert the outage? How are our SLOs impacted if component X is degraded for 30 minutes? Rank components by expected revenue impact of a failure within 7 days. So these types of questions need complex reasoning. I need an understanding of your business. You need to know what is an SLO? How does a component failing impact that SLO? And you need to rank components, you need some sort of prediction to do that, right? You need to predict what are the signals that you would need that should have triggered an alert. You need to exploit the graph nature of your system. If you have millions of components in your system and telemetry coming in from each of them, you better have some sort of graph system to understand the relationships between them. Let's look at security. So identify the top 5 highest security risk components in my system based on a threat model. Maybe you have a Stride threat model and you have all this telemetry coming in from your system, and you have an understanding of your components in the relational knowledge graph, and you want to understand which components are high risk right now. How does our risk score shift after rolling out some fix in the next sprint? Maybe the fix, fixes some component, some container running. How does that impact your risk score? Is it going to be better? Is it going to be worse? Produce 5 likely multi-hop penetration scenarios in my system. So, lateral movement, if there's an attacker and they can go through your whole system, what are the kind of scenarios there? These things require reasoning that go beyond SQL. You need to understand, you need to predict risk. You need to use graph reasoning. I think you get the point, right? I'm going to do it one more time. Cost optimization. Which containers can I scale down overnight to cut compute costs by 15% without impacting SLOs? Optimize log retention periods per team, so we never exceed some dollar amount per month while critical logs are kept for at least 30 days. Recommend which always-on services can migrate to serverless to maximize cost savings. Now, there's a new thing in here. Again, the overall theme is the same. There's hard questions that we need to answer about our business. We can't really do this with SQL. We need to go beyond. We need different types of reasoning. And we need a unified model, the relational knowledge graph, that we can query to answer these questions. In this case, there's prescriptive reasoning as well, right? There's constraints. We want to search the solution space, find a solution that stays within these constraints. 15% compute cost, no impact to SLOs, don't exceed this dollar amount, keep this for at least 30 days, etc. So I think you get the point. Now that we have all of this data, thanks to Observe, we can run our own system on our own telemetry to answer all of these really interesting questions. That's it from me.
All right, so as for Observe, we are dedicated to run AI power workflow on open standard data lake. That's why we will continue to our investment into the open standard like OpenTelemetry and Apache Iceberg. And we will also work on getting agentic AI in your hands to lower the MTTR and assist folks in getting your incident troubleshooted fast, in a fast and efficient way. And as for the architectural future of O4S, we are actively working on a data sharing solution, so the traffic do not go out of the network. And also at the same time, we are working on getting data from the information schema in your databases for more real-time and more detailed telemetry of your database usage. And of course, we have many more future use cases of O4S. So this will conclude our summit, and we'll be happy to answer any of your questions over there after the talk.
Yeah.
And thank you so much.
Thank you. Thank you.